Okay, so for this example, we now have picked a sample of 4 values. The first value is 5, and then 9, another 9, and 10. And this is drawn from some distribution which has a PDF given here. And we want to find out what is the maximum likelihood estimate for this parameter theta. Okay, so remember, step 1 is let's first set up the likelihood function. Okay, and so that likelihood function L, it's going to be a function of this parameter theta, given that x1 is equal to 5, and x2 is equal to 9, and x3 is equal to 9, and x4 is equal to 10. Then our likelihood function, now that we've got set values for all of these x values, the likelihood function is going to be a function of theta. So I would take what is the probability that my first observation would be 5. So that's f5. Times the probability that my second observation is 9, times the probability that my third observation is 9, times the probability that my fourth observation is 10. So this is telling me what is the probability of getting 5, 9, 9, 10. And so now I can use the PDF function for the distribution x. So the probability of 5 would be theta over 2 times the square root of 5 times e to the minus theta times the square root of 5. So now we actually know what the values of x are, and now the probability of getting that output is going to be a function of the parameter theta. So the probability of getting a 9 would be theta divided by 2 square root of 9 e to the minus theta times the square root of 9. The same, our third observation was 9, so we have theta over 2 square root of 9 times e to the minus theta times the square root of 9. And then for our last observation, which was 10, we would get theta over 2 times the square root of 10 times e to the minus theta times the square root of 10. So that's kind of the first step, is finding the likelihood function. And now we want to find a value of theta which maximizes that function. So let's first simplify this. So on top we have theta squared cubed, theta to the fourth. We have 1, 2, 3, 2 to the fourth power. And on the denominator, we have 2 to the fourth times the square root of 5 times the square root of 9 times the square root of 9 times the square root of 10. And then we have e raised to the minus theta square root of 5 and we have a minus theta in each of these, I should say. So we can write this as e to the minus theta. When we multiply e, right, we add the powers together. So we could write this as e to the minus theta times the square root of 5 plus square root of 9 plus square root of 9 plus square root of 10. So there's our likelihood function. And we could take the derivative of this directly and figure out what value of theta makes the derivative of L equal to 0, but it's going to be easier if we first take the natural log, and instead we're going to maximize the log likelihood function. And so when I take the log of L, I'm going to get a natural log of theta to the fourth, which we can write as 4 times the natural log of theta. When I take the natural log of this term, the natural log and the e are going to undo each other, and we're just going to get minus theta times, I'm going to shorthand this as the sum of the x square root of the xi's, and then we would subtract the natural log of the denominator, which is 2 to the fourth times the square root of 5 times the square root of 9 times the square root of 9 times the square root of 10. So this is what we get when we take the natural log of our likelihood function. And now we're going to take the derivative of that with respect to theta to figure out when is this derivative 0. So the derivative of the first term would be 4 over theta. The derivative of this term, this would just have a derivative of minus 1. So I would get minus 1 times the sum of the square roots of our x's. And then when I take the derivative of this, there's no theta in here, So this is a constant as far as theta is concerned. So finally, then we would want to solve for theta, this equation, after setting it equal to 0, and that would give us, if we solved for theta, we would get 4 over the square root, the sum of the square root. So I would get 4 over the square root of 5 plus the square root of 9 plus square root of 9 plus square root of 10. And that comes out to 0.351 approximately. And so if we look at the picture I've got over here, we are looking at the graph now of the likelihood function L of theta. So on the horizontal axis, we're looking at values of theta, and on the vertical axis, we're looking at values of L of theta. So for each of these thetas, what it's telling me is when I plug this into L, it's saying, here's how likely you would be to get the observed sample. So I want to pick the value of theta, which makes that observed sample most likely. And that occurs over here somewhere between 0.2 and 0.4. So that matches our estimate that we got over here. So the maximum likelihood estimate for theta we just found to be 0.351.